Okay, we are live.
Yay.
Okay, Massimo, I think that you don't need so much introduction. Thank you very much for joining the FabAcademy Recitations. This is the very first one of many coming during the year. We are doubling students and sites in the FabAcademy this year, and this is probably now the biggest distributed educational program in digital fabrication.
Wow.
So it's a pleasure to come with you, which I think that has been a lot of inspiration, and also we have built on top of the work that you guys in Arduino have been doing for the last 10 years or more. So with this introduction, thank you very much. The people is all yours. I will take some questions and feedback, and we'll point at you as long as we go. Okay?
So
thanks.
Well, thank you, Thomas. It's a pleasure to be here. I'm going to try to be as fast as possible with the presentation because maybe the questions are more interesting. But I'm just going to talk a little bit about how I got to the work on Arduino and what are some of the principles behind the choices that I sort of either made or we made as a group. I'm going to, by sharing the presentation, let's see what happens. Ta-da. And then this. Okay. Can you see the presentation, Thomas?
Not yet.
Okay.
Let me see.
Okay, entire screen share. It takes a second.
Now it's perfect.
Okay, good.
And now we lost you.
Okay, lost it again.
Yeah.
Impossible.
Now it's back. Yeah, okay. Now it's back. Perfect.
Okay, good. Okay. All right. Technology is not exactly on our side. So, so I wanted to start by showing a little bit where we came from in terms of, the work I do is a lot about making technology accessible to people. And the specific area I work on is mostly to do with electronics and what they call embedded development. So when I was a kid, this is the kind of magazine that you would see. So people would have these electronics magazines with like ladies on the cover talking about radios and other stuff. And then the projects would be mostly, I don't know, small radios, very basic electronic project that didn't have a lot to do in people's life. And they were very abstract sometimes. You would get this you get these schematics with very little explanation. And so this is kind of the way people who were enthusiasts about electronics, they wanted to learn kind of outside of the classic field. They had to kind of buy these magazines and just read them over and over again and try to buy books and figure things out. But it was never sort of, it was always never so beginners friendly. It was kind of this idea that the beginner had to suffer in order to learn. Then when I was a kid, actually what happened is that I was given this as a tool, as a toy, and it's a system where all the different electronic components are in small blocks that you can magnetically snap together, and you can build all sorts of different circuits with it. So the difference is that, yes, you're looking at a schematic diagram in a way, but each little cube contains a component. You assemble it, you can build a circuit, you can try it out, you can quickly move parts around. It's child safe. So I was 8 years old when I started to play with this. And it came with all this instruction where you would just look at the circuit, you would assemble it, and it would just magically work. And so each box, again, they call it sort of domino in this particular magazine, contained a bunch of parts into a transparent casing. So you could see the parts themselves, but they were just easy to manage, much easier to work with than a breadboard. And then it came with a book, this is a picture from the book. And the book had a bunch of explanation of how electronic works by showing little characters, and the electrons are these little red objects that move around. So the idea is that the introduction to the concept was made in a way that was, yes, child-friendly, but was also basically beginner-friendly. And then the electronics itself was easy to assemble, and so you could quickly try things out, and even if you made mistakes, you never damage, you know, the circuit in a way. So you could really explore freely. And one of the people involved in this process was Dieter Rams, the designer who worked for a long time for Brown in the 60s and 70s and later, who designed a bunch of these products, have been said to have inspired heavily a lot of the Apple products. So you can see there's like a bunch of Brown products from the 60s and 70s and some Apple products on the other side. So the idea is that this particular toy, in a way, got me excited about electronics. It got me interested about design, but also gave me an idea that you can create tools that are easy to understand for human beings. These are some of the laws that Dieter Rams kind of wrote a while ago about what good design is. And I think it's important to read this. You can find this stuff online. It's very easy to find this kind of stuff online, and you can read the rules and his explanation. There are videos of him explaining this. So there are some basic principle of how good design is, which you can apply to things that are not just chairs and tables and radios, but you can apply them to a lot of other things that people build. And again, what happened in the 80s, we got these personal computers. And again, if you look at the pictures here, this is a picture of somebody with an Apple II in a kitchen who is doing some graph, which is about sales, no? So imagine these people imagine that in the 80s, your personal computer, you would use it in the kitchen to do business graphs. So clearly there was a big disconnection between the fact that you could now have affordable computers that were cheaper and easier to use, and what actually people would do with these new devices. So this is one of the first computers I've tried, and it came as a motherboard, and you had to type hexadecimal numbers on it, because I was studying in an electrical engineering school. So we had to program these machines that were the ones that automate different things. So the computers were this kind of boards. No? So again, the problem was you have a new technology, it's very powerful, but the interface between you and this technology is complicated to understand. So this is an example of an early Italian computers from the late 50s, where the front panel was designed by Sozzas, who was like a famous Italian designer. And again, here at least he tried to find a solution on how to create a control panel for this very, very old computer that would have some principles of simplicity and information visualization all embodied in this control panel, which is radically different from a lot of the other panels you see from similar computers. So in a way, design tried to kind of get involved in the computer design at the beginning, but they was still kind of very far away from having a strong impact. So this is another computer I had when I was a child. This one was very different. You would plug this into a TV. When you press the buttons, the simple basic language, when you press the button, entire commands will be written out. So you didn't have to type everything. And it was very, very simple to get a program going. So it came with a fairly beautiful manual. You would read examples, copy them in the computer, press a button, and things would happen on the screen. So this was a very simple, reasonably cheap thing that would plug into your home TV, and you could learn about programming in a non-threatening way. So I think, again, this was attempts at making the technology cheap and accessible to people. I guess what happened in the early 80s till the sort of mid-80s was that there was a lot of companies that jumped on the market and tried to do this kind of computer. So in Europe, there was Sinclair with the Spectrum, there was Acorn with the BBC Micro and a bunch of other products. There were a number of other smaller companies. Even IBM tried to get a PC Junior, sort of a cheaper PC for home use. So in a way, again, we're talking about trying to make technology more accessible to people. So this was the guts of the computer. it was a very simple design. It was only 4 chips, so which made it sort of easier to understand as a piece of hardware. And this is the manual I was talking about, which was reasonably easy to use. The basic language is an old 1960s language, but it's a very simple language that it's kind of easy to learn when you're just starting out. So if we forward a little bit, because we are, though we don't have days, in 2002, I started teaching in this design institute in Ivrea in the northwest of Italy. So this building here, it was the R&D building for Olivetti, the typewriter and computer company. And it was actually the inside of the building had been refurbished by Sotsas, the same designer I was talking about at the beginning. And here we try to experiment with what they call interaction design. So what happens if you take design and instead of applying it to chairs and tables and lamps, you try to apply it to the way people interact with technology. So my job there was to work with students and help them build prototypes, design with technology. So in a way, we did a lot of different experiments. I don't know if you can watch the video because I don't know about the connection, but this is a wallpaper that could display messages. And it was one of the projects that we did at Ivrea. So it was very intensive. So here you can see a couple of students at 2 o'clock in the morning, sort of sleeping on the table, because we had a 4 weeks class and we worked many, many hours every day to try to get to the point that we had something working that we could show to people. And this was, again, a big change compared to a lot of other design schools, which prefer either rendering or they prefer kind of, prototypes that are made of foam. They don't do anything. So you have a beautiful shape, but it doesn't do anything. While our objective was to actually have something working really quickly so that people could really experience their designs with human beings and figure out if they worked or not. So a lot of the work there was inspired for me by this book by Eric von Ippel, which is about the democratization of innovation. You can find this book for free, downloadable from his website. But he started to talk about this process of user-centric, democratized innovation, how if you create tools for people, they can innovate. In fact, one of the parts of the book is talking about this toolkit, that he envisions the fact that you can involve people in the design of things. Company can involve them in the design of products and services and what have you by setting up a learning process which is about trial and error and have an appropriate solution space. So in a way, let's put it this way, not try to solve every single problem in the world, but produce something that can solve a certain category of problems in a well-defined way. A user-friendly toolkit, commonly used modules, and results easily created by the user. So in a way, we were inspired by this, and we provided all of these elements without even actually doing it consciously. So we came to sort of the same conclusion in a trial by error process. But then when I came across this book, I realized that a lot of principles matched. And again, when I started working, this is the kind of tool that people use to develop with microcontrollers. They had these very complex boards with lots of connectors and everything on it, and serial ports. So, at the beginning of the 2000, people still had serial ports on these kind of devices. So USB hadn't really completely landed on these things. But my students were mostly all using Macs, which means that if you have a Mac, you want a USB connection because Macs don't have serial ports since the mid-90s or even before that. So this is something that, again, students were looking at this kind of technology and getting a little bit scared. And again, this is another picture of how the process of developing with this kind of tools is. You have all these dongles and cables and development environments and cables going all over the place. So we did a lot of work that started in 2001 when the first people came to Ivrea, and one of them was Casey Rees coming from the MIT Media Lab, who had just been working on a project called Processing, which was a tool that was very useful for us to teach students about programming. And then, once we started to teach students with processing, I started to work on electronics in 2002, and I started to experiment with different kind of technology. And then I came to the first sort of platform, which was called Programma 2003. Then we did the wiring project, which was a thesis project. And then a lot of the information that came out of these two projects and the work that other people like David Quartierius did and Tom Igo kind of merged into what then became Arduino. This is a graph that was built by a former student, Giorgio Olivero, back in 2005 by interviewing all the people that were involved in Ivrea to understand how the different projects had kind of ended into each other. And this is a picture of the first product, Programma 2003, which is still not really nice to look at, but it's a little bit simpler. It's a simpler, small board that you just plug in, and it made it a lot simpler for people to build things, and we had lots of projects built with this. And then this made me understand a lot of things that didn't work about this approach and how I had to improve in that direction. So these are some pictures of the first products being assembled by hand. But then this group formed with David Quartierius, David Mellis, Tom Igo, and originally at the beginning, Gianluca Martino. And one of the things that we did when we designed the first Arduinos was we wanted to create a tool that would be cheap, that you could assemble yourself if you wanted to, that would be open so that people could, create, could derive from the design, and would make it simple for people to learn about programming microcontrollers and doing electronics the way we do it, in this century. One of the advantages of using these small computers, these little microcontroller chips, is that when I learned electronics, you had to build circuits from individual components, from resistor, capacitor, transistors. Every time you wanted to change the behavior, you had to redo the circuit. While in this case, you could change the behavior of a device by just changing the code a little bit. And this is a huge step in making things and the boards. There were quite a few on the market. The real difference was when we started to take all these different elements that we put in the different projects, and then we had this amazing GCC compiler for the AVR processor. We took inspiration from processing, we had Java, we had other softwares, and then a lot of community contribution, the learning that we had from the Programma 2003 and wiring, we put it all together to create Arduino, which is effectively a mashup of open technologies. So it's a mashup of a lot of different technologies, but what we did, we designed the experience. And I think what's different for me is, again, designing the experience sometimes is more important than how powerful is the technology that you have. So we decided to try to, release the hardware, software, and documentation as with an open source license, and then sort of deal with the brand in a different way. A lot of inspiration also came from this TED lecture from this professor from the University of California, who looked at the way fashion brands deal with this kind of world where you cannot, there are some places in the world where you cannot trademark a shirt, or you cannot protect the design of a shirt or a pair of pants or skirt. You had to, anybody can copy it. So if you're in a world where everybody can copy, one of the things you can try is to have a brand and kind of work on that brand and put your logos everywhere so that people understand that that's your version compared to other people's version. So this is a picture of the hardware as it is now. This is the basic board. Genuino is the brand we use in all the markets outside of the US. So this is a new Genuino Uno, which is the basic product people learn. It's a very basic computing platform, which is very similar to the original Arduino that kind of came out in 2005. We also have other models that we designed over time with more powerful processors running Linux, with Wi-Fi, with Bluetooth. But this is the basic kind of, hardware. So what we did, we designed the hardware, made it available as open source. We created a software that you can use to program this hardware. And again, by getting a lot of inspiration from processing. And we tried to package up also with documentation. So this, for example, it's a book I wrote about Arduino that tries to get people involved in the project, making them understand what it is all about. And it's interesting because somebody sent me this email saying, as an engineer, I found the first 18 pages to be fluff, but I'm sure it helps appeal to a younger generation. So the interesting thing is that there is this interesting tension between engineers that are classically trained and people who are trying to learn and they don't have a technology background. So the first 18 pages of fluff, it's essentially me trying to explain the Arduino philosophy and trying to explain to people that have no background in technology how they can approach these kind of problems. And in a way, I realized that in the world of trying to explain technology to people, if you're building a tool for kids, you're allowed to do whatever you want because it's for kids. So everybody loves kids and it's fine. But as soon as you try to make something simple for adults, you get a huge amount of criticism. We got a lot of people complaining that we were making people stupid by teaching them the wrong way. So in a way, when you're trying to make things simple for adults, you in a way collide with a lot of existing people working in that particular field who are not happy about somebody coming in and providing different approaches or something like that. So this is the Arduino development environment, which now supports a bunch of doesn't support only the products that we make, but supports all the products that the Arduino community uses. So there's a bunch of companies or even individual makers who have adapted the Arduino programming library model, in a way, to other hardware. So in a way, now the Arduino IDE supports a bunch of different bits of hardware, not only the ones that we designed directly. And somebody defined the Arduino as a baby talk programming for pothead. Because again, this AVR Freaks is a professional community, technically, for people who are experienced in programming microcontrollers. And for them, again, the attempt at making something simple, and also, Arduino started off for designers, artists, musicians, all this kind of stuff is baby talk for pothead, for people who are, again, an artist for these people is seen as somebody who smokes pot. So in a way, it's interesting, again, the clash between different types of way of looking at technology. And also, I will skip this as a sexist comment. But in a way, one of the things that we try to do is to design even the electronics to be visually appealing. Because we wanted, since the PCB, in a way, it's naked. So the way the electronics is laid out on the PCB is one of the strong points, is that what makes this product stand out compared to other products where there is no interest whatsoever in a way, to make it more easier to understand, easier to interpret, where they just put the parts on the circuit. And so we did a lot of work on the packaging. And again, this is the person who designed all the packaging is, again, Giorgio Olivero, that was my student and now is our sort of creative director. So we did a lot of work also in creating these kind of little posters to put inside and kind of the little details of how the board snaps into the cardboard. So there's quite a lot of work that went into try to give the product a visibility, and it's interesting because before we started to do this, people in our market, they never put any branding on their board. They just put the name of the board and that's it. So they never really cared about the graphics. So I guess we kind of spearheaded also that attention to this kind of details that now people start to have. And obviously you have people who kind of, make their own version of the board and they pass it on. as like official. So this is a Chinese clone found on eBay, which is marked as the 2011 official version. You can see that the graphics is very different, so it's not exactly official. They even have versions where, some of the products in Arduino are made in Italy, and these people even copied the made in Italy, but they did it, not really kind of doing it exactly as the original. So, but again, this branding is seen as some kind of a value. Another area where we worked a lot, again, is the way we do the documentation. This is the Arduino Starter Kit, or the Genuino Starter Kit, depending on where you are in the world. And originally, this was the workshop kit. This was a bag of components, which I made the list of the parts before a workshop in Barcelona in 2006. And that became the official workshop part list for Arduino. And some people still sell kits with the same parts, which, this also, again, tells you the story of how when you come up with something for one specific occasion and it becomes, somehow some kind of a standard. And now the starter kit tries to have an approach where you have a book with 15 different projects of increasing complexity. You have a bunch of parts, and you can build things that are cardboard parts. Again, we're trying to, the out-of-the-box experience is very important, because you open the box, that is the book, you lift the book, the parts are arranged in little boxes. So this is what you find in the kit. Again, we try to create a path for people to go from zero to making something that works, and introducing a different aspect of microcontroller programming for every step. And again, I think this is a product that sells very well, and even it's the most expensive one on the market in this category. The quality of the product, the way it's designed, it's a winning factor for people. There's some pages from the book where you see layouts and instructions, and again, this is another product I designed originally to be a little bit like a game controller that you could program, that had a bunch of sensors on board, that didn't require you to build any circuit in order to be useful. And it was interesting. A lot of people built things with this. It didn't have a lot of success because it was way too expensive, but the concept lives on in a bunch of other products that people build after this. But again, the idea is, can we make a board that doesn't require you to build any circuit, that comes with a bunch of sensors on it, that you can just use it right away? And again, this is not the most powerful microcontroller platform. They're all kind of basic 8-bit microcontrollers. And the interesting thing that you see as a recurring theme is that people build all sorts of crazy applications using 8-bit microcontrollers, because they can understand them deeply due to the documentation and the framework that we created. And only people who are very experienced venture into 32-bit microcontrollers, because they rather kind of squeeze every bit of power out of the simple products that we make than to try to learn how to use one of those big boards with lots of parts and with kind of very complex user interfaces. The robot was, again, another attempt at creating a product which would have like very easy to understand instructions, and so we did a bunch of analysis on the website, to try to understand the kind of behaviors and who are the leechers and the seeders, using some kind of a BitTorrent terminology. So the tone of voice. So we studied a little bit the different personas and the way people use the website to try to also create a tool that would be integrated with the rest. So to me, it's very important. And I think one of the things I learned is that people respond very well to if you create the whole platform. If the hardware and the software and the documentation and the website and the tutorials have a similar voice, similar tone, if you provide something which is integrated at every level, and you can allow that, you create a tool for the community to talk to each other, you create the software tool which is open, to external contribution, but works very well with your products, and your products in a way are designed to be recognizable and sort of, where a while ago, this British architect Usmanak said that sometimes our job is to put quality where it doesn't matter, and actually it does matter. The problem is that sometimes in some of the things that we do, on the surface people say, oh, we don't need that level of quality, who cares, it's just a PCB. But then when you do put quality where it doesn't matter, then magically people perceive it instinctively. They don't perceive it maybe rationally, but they see the difference in the way you cared for the way things were built. So I'm going to close quickly by showing you a couple of examples of what I think some of the interesting trends that are happening in our world right now. So one of the cool things is that there are more and more visual tools for people to try to use electronics creatively without having to be an expert. So fritzing, for example, it's a tool that allows you to capture a circuit you build on a breadboard. And when you draw it on a breadboard, it extracts automatically the schematic diagram, which can be complex for a beginner. And it also allows you to design printed circuit boards, which you can send to a factory with a click, and you get back the PCB. So this is a PCB generated by that diagram you saw before. So again, these kind of tools that guide beginners to the point of making a PCB without being like a hardcore engineer, these are an interesting tool for us. There's going to be tools where you will have macro blocks of consumer electronic products that you would just drag to your circuit, you would just snap them together. You wouldn't even know what they do, but I'm trying to build some kind of a mobile phone. Okay, let's just drag the power supply for a mobile phone. Let's drag the processor from a mobile phone. Let's drag the screen onto this tool, and you connect them together. You generate the printed circuit board. And some of these tools are even getting to the point that not only you get a blank PCB, but you can actually get a completely assembled PCB. And this is the same tool as fritzing in a way, but in the cloud. This is 1-to-3D circuits from Autodesk now, which also has a basic simulator for Arduino code. So if you have Arduino code, you can actually run it in this basic. It's a simple, it doesn't actually simulate the whole Arduino because it's not a simulator for the microcontroller per se. It's like an implementation of Arduino in JavaScript, but it's good enough for you to understand the interaction between the code and the electronics without actually having to build anything. So one of the things that is going to be a big trend now is a lot of these tools are going to be in the cloud. So you'll have a browser and you can design PCBs, you can design circuits, you can assemble circuits, you can you can program. With Arduino Genuino, we actually now have a version of our development environment which is completely in the cloud. So you log on to your Arduino account, you go to create on arduino.cc, and in a few weeks, almost every Arduino user will have access to this tool. And again, it's the advantage of working in the cloud. Your sketches are all up there. You don't have to install almost anything on your computer. So there's interesting trends due to this. And the other thing is what I call object-oriented hardware, in a way, which, this is the Tinker Toolkit, which is something I started in 2006 for a company called Tinker I was involved with. And the Tinker Toolkit, again, was a way to put a bunch of sensors and actuators on modules and kind of snap them together with connectors that you cannot mistake. And I think this is, again, this idea that you can package up well-known functions that are part of building an electronic system, like a phone or a Wi-Fi scale or whatever other machine. You package them up, you make them pluggable into each other, and then you create working systems without having such a deep knowledge of every single system because you design them in a way that they can be kind of put together easily. Another example is what the work that Little Bits is doing. In a way, they have taken the work that Dieter Rams did with the snappable blocks, and they gave them a different one, kind of more, they took it to a next level, and they're doing, a pretty amazing job with this. And also we have a tool that we made a while ago. I don't know if the video is gonna work, but I'm gonna try. So I'm not sure how much of the video comes through from the streaming, but this ESLOV is a research project started by our office in Sweden, which is about packaging up sensors, actuators, other parts of a consumer electronic device into modules that all have a small processor on board. We've been working on this for a couple of years now, and we have a few hundreds of them on the field trying that for people to sort of work on, and they are part of a European research project. But the idea is that when you assemble the modules, the software on your computer becomes aware of what modules you plugged in. So you can create interaction between the different modules just by drawing lines on the screen. And also the modules themselves are solderable. They can be mounted on a PCB. So you can actually solder them up on a PCB, and you can create a robust prototype for example, a heart rate monitor or another tool just by soldering these modules. And I think this kind of future where sensors will have microcontrollers inside of them, and they will not communicate to the outside world with simple, like, basic electrical signals, but they will communicate over digital buses. It's becoming now a reality. It's becoming now a trend that will become very important because, again, a lot of the parts that we assemble on a circuit, they will become modules that you connect to a bus, and then you create the connections in software, and it becomes less and less of an issue of how much do I know about wireless connectivity, and it's more about what kind of wireless modules, CPU modules, power management modules, sensors, actuator modules can I assemble together to create what I'm trying to create. So, and I think this is where I think this is going. A lot of the electronics will become a work of assembling predefined components. So there will be sort of a kind of a different parallel development streams where a lot of people who are interested in developing applications, they become integrators of different modules, while there's going to be other people who are more designing those modules, inventing those protocols, and inventing all the different ways these parts talk to each other. These tools also open the way for automatic PCB manufacturing, because the moment you describe the connections between these different modules, you can actually process the information and produce a circuit. And so online tools or desktop machines can make circuits that are very powerful, with the designers knowing not that much about the technology. So let's see, let me turn off the screen sharing. So the idea is that, so I try to show a little bit what I've worked on in the past and what I'm interested in right now. And also, as I said, the title was People Over Megahertz, because I think it's very important that we try to take care of the user experience of people and less about how many megahertz you can put on a circuit. I saw now development boards that are running on 8-core processors. And it's hard to understand what are the use cases where you need an 8-core processor all the time for all the applications. So it's about understanding how much value you can give to people with the least amount of processing power. Thank you.
Thank you very much, Massimo. I cannot share with you the applause, but I guess that people in more than 73 places in the world that are connected now, wow, including Peru, Shenzhen, England, Amsterdam, London. I cannot tell. Everyone has been saying hi in the Hangout channel. So people can think about sharing some questions if they are. I have a lot of questions. I can start also with a comment, which is when I did the FabAcademy back in 2008, we were using assembler, Massimo. And Arduino was almost forbidden to be used in the FabAcademy.
I remember.
And
I remember.
and now it's becoming a really helpful platform because students are encouraged to create their own versions of Arduino. So we're using firmware, software, but the hardware is being modified, which is also an interesting playground, probably for you guys as well as the Arduino team. So I think that funny Arduino versions are going to come out of the FabAcademy eventually, no? So I wanted to learn, and connected to that, I wanted probably to know more about, well, I know that a lot about it, but probably you can share more about the Arduino at Heart program. So imagine what happens with a great invention coming out of the FabAcademy, how that can be connected with the Arduino ecosystem, where is it going now, and if it's the right question to ask, I want to know.
Well, at the moment, kind of an experimental thing that we tried a few years ago. At the moment, we are rethinking that. I think at the moment, what people are mostly interested in is that they understand that Arduino.cc is the Arduino community, and the Arduino IDE is downloaded once every 4 seconds. So there are usually maybe couple of million downloads a month, which is a lot. And so what a lot of people are interested in, they want to be in that IDE. So I guess most of the work that we are doing right now is much simpler. We just help people be in the community, be well known to the community, and be in the IDE. So one thing that we did is that you can actually work directly with us, and we can put that product. Or actually, you can we created a system where you can actually just put one JSON file online that describes the software that you use for your device, and you just tell the users, go on the preferences, add this JSON file, press OK, and then any modern Arduino IDE will understand how to program and how to talk to your device. And I think that was an important evolution. We wanted to be more open and not work just with our own hardware, but we wanted to enable as many people as possible to use our development environment with their hardware. And I think that's more what we are doing right now. We're just letting people sort of be more part of the process.
Okay, I have another question, which is probably related to, there are two things. I mean, how open source adds value both to innovation and also to businesses? What's the value added in terms of, in the innovative process, I guess is more or less clear. Probably you can tell us about that a little bit, but in the business side, and I want to connect that with your project, you can tell a bit about your partnerships with Intel and Seed Studio in China.
Well, these are all, so from a business perspective, it's always tricky to make open source work in a business environment, because there are some parts of, for example, software where this open source software is more mature in a way. So in a way, people work collaboratively on foundation tools they share. But in a way, each company is making their own software, which they're selling in a way or another. So they're making service they build on top of the tool. In the Arduino world, there's still a little bit of, I guess, confusion between the fact that we do a lot of work on the tool itself, and we share it as open source. And so there is still a lot of people who just take and they never contribute back, and it's gonna be a problem, I think, in open source hardware, because essentially, I think the days where you can do open source hardware completely independently are probably over, unless you can create a business on the side that supports that. But usually, the best way to do it is to do it in partnership with a silicon vendor, the people who make the chips, because obviously they can support and help create these kind of open source tools because they have an interest, because they sell the chips. If you're completely open source hardware, you're basically giving away everything about your business. And then there are few small areas that are not open source, like the chip itself or the modules. And so the people who make modules and the people who make chips are allowed to be closed source, and you have to be open source. And every time we do something that's not 100% open source, we get a lot of criticism. So clearly there's a problem in how do you make this work from a financial point of view. So I think it's a lot about creating premium version of your tools that are not completely open source, or services that essentially built on top of the platform. So it's if you're making a product which is a very specific use, you can potentially open source a part of the project and the way you program that product. So you can have a closed open model, which is kind of half and half in a way, where you can still sell the device without people sort of just copying it and selling it, but then allow people to innovate on top of the device.
So I have a couple more questions from the network. Another one is I read it literally, is we are starting as a network to think about decentralized manufacturing. What would be your advice on this? Do you think it's feasible to use the FabLab network powers to shift production back to the local? It comes from Fiore Basile in Italy.
Well, the question, I think, at the moment, I see a lot of Fab Labs, in a way, dealing again with the problem of what's my business model. Because either you are supported by a company which kind of puts the money for that, or you're supported by some kind of a foundation type entity which again collects money, or it's not easy to keep the system, to keep the Fab Lab going. So I guess finding ways to be useful to a certain local area or market is probably a good way. And also, I guess, manufacturing some products locally, it's another area. Is if you look at the work that people at OpenDesk are doing, you can go online, you can select an open source design for a piece of furniture, and you can select a partner in the world, which is the one closer to you, which will make it for you. So in a way, a well-equipped Fab Lab that has very well-designed software interfaces on top of competent people can potentially be this local manufacturing hub for designs that come from online tools. And because some people like the idea that, yes, I found this design for this chair online, but who's going to make it for me? And then I realize there's a place near that I can go to, and I can see this thing happen. I think that's a potential area.
Another one, I think, coming from Francisco in Sitges, near Barcelona. Any plans for a cheap minimal Arduino for IoT?
Well, so at the moment, we have sort of pre-launched this product, which is called Maker 1000. And we launched it for a competition we did with Microsoft and Hackster. It's essentially a stamp-sized Arduino, which comes with Wi-Fi, hardware encryption, a 32-bit ARM processor, and also the power supply that manages LiPo batteries, so you can charge them. So in a way, it's designed to be like a small module that it's the heart of an IoT product. So you have the complicated part is processor encryption, connectivity, and power management are on a board with a new form factor, which we will use to do a lot of other products. And we created a contest with Microsoft. We received over 1,000 ideas. So the first 1,000 people who submit a complete idea will receive one of these boards for free. And then in 2-3 months from now, the people will actually build the project, and then based on that, they will win a number of prizes. But I think it was interesting to see the response to this particular tool, and that's going to be, I guess, a lot of the work that we will some of the work that we will do in the future is to kind of enable these kind of connected products by not only providing the Arduino board, which is kind of bulky, but providing more like a set of modules that you can use to quickly set up a product.
Okay. Well, thank you, Massimo. I don't know if I think that those are questions. I think that we don't have more questions from the network now. So those were really, really good questions. I think they tackled some of our concerns and our links with the Arduino community. I don't know if you have any comments or probably some sort of recommendation for anyone that wants to start something like Arduino.
Please do.
Okay.
All right. Thank you.
Thank you. That was amazing. This will be posted online. See you soon and stay in touch. Okay.
Yeah. Ciao. Ciao.
Ciao.
Bye-bye.